Hello, herdlings! How are you? We are starting another episode. The show where intelligence lacks only on the host side, the one who speaks to you. I always bring more intelligent people and with lives more, how can I say, astronomical than mine. About the
Interstellar.
Is it better? Okay. Let me introduce you guys. Who's first? Sakani. Can you start?
Hi guys, it's an honor for me. I read the Avi book Extraterrestrial. That's very nice. And let's talk about the interstellar objects and mainly about the 3I Atlas. That's a huge mystery object entering in the solar system right now. Thank you everybody to see us here.
Philip behind me, it's you.
Hello everyone, thanks for watching us. Today we're going to talk about life, universe and aliens, especially with Avi Loeb, the best expert. We have a lot of fans here in Brazil, Avi. You must visit us once in a while.
Thank you. Well, I should say I have half of my DNA is Spanish, and that's the better half. And the other thing I should say is that I'm seeking a higher intelligence in interstellar space because what I find here on Earth is very limited, which is the name of your podcast.
Yeah, we agree. We agree about that. We listen funky here. It's a kind of a rhythm here in Brazil. I would like to explain that Daniel Lopez sent us previously some question. Is that right, Jaime?
Yep, he sent us a video.
Yeah, we will show later. And Loeb, can you call Loeb Avi?
Yeah, you can call me by my first name. You know,
Avi.
I haven't changed at all since I was a kid. I grew up on a farm and you know, I just played soccer 2 weeks ago with the students at Harvard, and we lost 3-2, but I managed to score the 2 goals for the faculty. So I'm still doing well. You can call me by my first name. I'm not formal, yeah.
Welcome, Avi.
Let me start the show.
Okay.
Let me start the show. I have a good question for you, Avi.
Yeah.
When did you first become interested in the question of life beyond Earth? Was there a specific event or inspiration that set you on this path?
Right. So you see, I see science as fun because it's an opportunity to learn something new. And the way we can learn something new is not by getting likes on social media. It's by, observing nature, collecting data. And in 2017, the telescope in Hawaii called Pan-STARRS discovered the first object from outside the solar system near Earth. And that was, just 8 years ago. So before that, I worked on black holes. I worked on the first stars in the universe, which is the scientific version of the story of Genesis. You see, I'm selecting topics that matter. You open the Bible, the Old Testament, you see a story in the first chapter talking about how the universe was created. I wanted to figure it out without believing stories. I want to see if indeed what we observe in the sky is consistent with the biblical version. And I wrote 2 textbooks on that. And now the Webb telescope, I was on the first committee that designed it in 1995. And now it's getting data on the first stars, the first light in the universe. About 100 billion years after the Big Bang, 100 million years after the Big Bang, the first galaxies and stars formed. And we can see them now with the Webb telescope. That's remarkable. And before that, the universe had mostly a mix of ordinary matter and another form of matter that we don't know what it is, dark matter, plus radiation as well. What if we go all the way back in time, there was the Big Bang, but we don't know what was before the Big Bang. So these were the interesting questions I was trying to address for about 3 decades in my career and as an astrophysicist. And then in 2017, there was this object from outside the solar system. All the astronomers said immediately it's a comet because we've seen rocks in our solar system, and some of them are icy, and when they get close to the sun, the ice evaporate, and you end up with a tail of gas and dust, and that's a comet. And for me, it wasn't obvious because, if you go to your backyard and you find an object from the street, of course, it could be a rock like all the other, rocks that you know about in your backyard, but it might also be a tennis ball thrown by a neighbor. And this object that was discovered in 2017 was given the name Oumuamua, a scout in the Hawaiian language. And amazingly, there was no dust or gas around it. So, just like the kid in Hans Christian Andersen's tale, I said, the emperor has no clothes. We don't see the clothes. And the adults in the room were saying, oh, no, this emperor has clothes. They're just invisible to you. And, I hate it when the adults in the room pretend to know something that they don't really know. I really hated it when I was a kid. And believe it or not, even though I had a lot of leadership positions, I was chair of the astronomy department for 9 years, director of 2 centers at Harvard, chair of the board on physics and astronomy of the national academies in the US, and a member of the President's Council of Advisors on Science and Technology in the White House. Despite all these leadership positions, I did not change the way I think. I'm curious about the world, and I don't care what the adults in the room are telling me. All these stories that you either read in the Old Testament or my colleagues in academia are telling me, I want to see the evidence to support them. And so to me, this object looked really anomalous because it was pushed away from the sun without showing any rocket effect, no evaporation. And moreover, it was most likely flat because the brightness of the object changed by a factor of 10 as it was tumbling. So it was modeled as a pancake, a disc-like object, very strange, unlike the rocks we have seen before. And I said, maybe it's technological. So that's what started the journey for me. And, my colleagues made a big mistake because they started dismissing it and attacking me personally. And at that point, I said, no, I will, this is science. This is not supposed to be, a social event where you are trying to be liked. It's a question of what is the object. I recognize that the Vatican, the church, made a big mistake when they realized that Galilei claims that he can see moons around Jupiter through his telescope. Now, what they did is put him in house arrest, trying to argue you should not speak to the public about it. And instead, what they should have done is say, we have more money than you do. We can build a bigger and better telescope than you built and prove that you are wrong. And if they would have done that, they would have realized that he's right. Now, very quickly. But instead, they waited 350 years after he died. And then in 1992, when, that was 2 decades after humans reached the moon already. So in 1992, they said, oh yeah, Galileo was right. And that was very embarrassing. It's a very bad public relations stunt, like to say 350 years ago, we were completely wrong. We put a person at house arrest and he was, and so I realized that we should be guided by evidence and not by prejudice, not by the authorities. And so it also happened more recently. We will talk about 3I Atlas because this third interstellar object, 8 years later, also showed anomalies, and we will talk about them. And I basically wrote a paper just a few days after this object was discovered, 3I Atlas, and I said, these anomalies could be potentially explained if it's technological. And the editor of the journal that I submitted the paper to, he said, remove that sentence. This was the concluding sentence that said, basically, these anomalies could be explained if it's technology. So he said, no, remove this sentence. Okay, so I couldn't get it published unless I removed the sentence. But as a result of him saying, remove this sentence, I wrote a full paper, extended paper, just on this issue of whether it's technological. And I did not go to the press. I did not speak. And then it became viral all over the internet, all over, the world. People just talked about it over the past 2 months. And, that's my approach, is that we should not be guided by authority. I have the mentality of a child that wants to figure things out for myself. And this approach was the result of the first interstellar object and now the third interstellar object. That's when I started to be interested in the possibility that there might be objects visiting us that are technological, and that we might not be the smartest kid on the block. As I said before, we have limited intelligence.
Can I ask another question? Because now I was thinking, when interstellar objects like Oumuamua or 3A Atlas are discovered, I mean, we know that it's astronomers at observatories who first collect and report the raw data, long before intelligence agencies might even be aware. So if hypothetically 3A Atlas turned out to be an alien spacecraft, do you think it would even be possible for a government to suppress such a discovery before the scientific community noticed? Or
No way.
would the nature of astronomy with open distributed observations make that kind of secrecy nearly impossible? What do you think?
There is no way to suppress the flow of data, because there are so many telescopes that can be used to look at it. There was a claim somewhere in social media after I talked about the fact that it could be technological in origin. So someone said, well, this is conspiracy, that such an object doesn't exist, and Avi is part of the government telling us that. And I said, okay, well, go ahead and buy a 0.5 meter telescope that you can purchase as an amateur astronomer and just look at the sky. For me to generate an object in the sky that is at a distance of 4.5 times the Earth-Sun separation is practically impossible. And moreover, it was looked at with space telescopes like the Webb telescope, the Hubble Space Telescope, and they can all confirm that it's at a very large distance from Earth. I cannot produce such an object. I would be much more powerful than the Pope if I could have done that.
And right now, the amateurs are start to observe the 3I Atlas here in Brazil. The last weekend, we have a lot of live in YouTube that the people in the south of Brazil, in the middle of Brazil, the National Observatory of Brazil promotes a big meeting of the amateur astronomers looking the 3I Atlas. So right now it's impossible, to hidden from the public or some.
Yeah. So 2 things about that. One, this object was discovered by a relatively small telescope, 0.5 meter in diameter, in Chile, that is called Atlas. That's where the name came from. And 3 means it's the third interstellar object that was discovered by a telescope. So it's 3I for interstellar and then Atlas. And Atlas is in Chile, just neighboring the much bigger telescope, 8.4 meter, that was inaugurated in June, called the Rubin Observatory. And the fact that a small telescope discovered this object means that it's relatively bright. And as soon as it was announced, I calculated that it must have a diameter of order 20 kilometers in order to reflect the amount of sunlight that was reported. And that's a huge object, as big as Manhattan Island. Most recently, the Sphere X Space Observatory observed this object in the infrared. And from the fraction of the amount of sunlight reflected at a wavelength of 1 micrometer, they concluded that if it's a solid object, it has to have a diameter of 46 kilometers, even bigger. And of course, there are two ways to resolve this problem. One is to say, actually, the object is much smaller and it's surrounded by a dense cloud of dust that reflects sunlight. But in that case, we would see the dust pushed by radiation from the sun, pushed behind the object. That's the way comets look like. And at least in the early days, it wasn't really clear that there is anything behind the object, nothing trailing it. There was some glow in front of it. So the dust possibility has an issue. And the second possibility is that this object, is not a rock. Because if you calculate, you find that if it was a rock, it had to be 1,000,000 times more massive than the previous objects that were discovered, like Borisov was a comet, that was the second object in 2019. And Oumuamua also in 2017 was roughly 100 meters in size, so size of a football field. So both Oumuamua, the first object, and Borisov, the second object, were on the scale of hundreds of meters. And here we're talking about an object that is hundreds of times bigger than that, and so 1,000,000 times more massive, and it just makes no sense that you get we didn't see 1,000,000 small rocks before we saw a giant rock. And moreover, there is not enough rocky material in interstellar space per unit volume to deliver such a giant rock, 46 kilometers in diameter, to our backyard, to the inner solar system in 1 decade that we did the survey. You expect it to take at least 10,000 years or 100,000 years for such a rock to appear. And so obviously a way to resolve it is to say it's not a rock. It's actually technological in origin, and it was targeting the inner solar system. And in fact, when you look at the trajectory of this object, it's very fine-tuned. It's aligned with the plane of the orbits of the planets around the sun, to within 5 degrees. And the chance of that alignment is 1 in 500. And so that raises the question of whether this trajectory was designed by some intelligence. And also the timing of the arrival is such that it's getting very close to Mars on October 3rd, 2025. It will get within 29 million kilometers from Mars. And actually, just an hour ago, I calculated that if 3I Atlas has a probe just ahead of it, about 200 million kilometers ahead of it, that probe may actually come extremely close to Mars when it gets close to Mars at the beginning of October. And it could actually intercept Mars. However, 3I Atlas will pass at some distance of 29 million kilometers from Mars. But if it has a probe just ahead of it, that could intercept Mars. And why would it come so close to Mars? And then it comes close to Venus, and eventually it gets very close to Jupiter on March 16, 2026. And so the coincidence of that is with a random chance of 1 in 20,000, actually. And I just think that we should monitor it, because maybe it is technological, and obviously the way to find out is by getting more data.
I think the main difference of 3I Atlas for the other two interstellar objects is the fact that we discover when the 3I Atlas is entering the solar system. Then you have a lot of time to study, because Oumuamua, when you look to the Oumuamua is very far from the Earth and leaving the solar system. And Borisov, we don't have a lot of data or a lot of images of the two previous interstellar objects. I believe that this fact is very important for the astronomer, because we have a chance right now to really study an interstellar object, because we have almost 1 year of the time to make a lot of measurements, use a lot of the telescopes, different kinds of telescope, James Webb, Hubble, Vera Rubin and another telescopes in SPHEREx. That is a new mission that we just launched. So I think that is the for me is the main difference and the main point about the 3i Atlas is this point that you can have a lot of time. The amateurs and around the world can right now look to the 3i Atlas and make images of the 3i Atlas. I think that is the main point
Right.
for this object.
But in addition to that, because it comes so close to Mars,
To Mars,
29 million kilometers, and
we
if
have
it has
the
if it has a probe that is preceding it, let's say by 20 million kilometers, that could actually intercept Mars. So there is actually around Mars a camera called HiRISE on board the Mars Reconnaissance Orbiter. And this camera, when 3i Atlas comes closest on October 3rd, it can get a high-resolution image with a pixel size of 30 kilometers.
30 kilometers.
And so that could resolve the object, and that would be our best bet to tell how big the object is. But I actually, as of today, when I calculated that the precursor probe could actually intercept Mars, I think it should also monitor Mars to see if there is any mini probe approaching it. And I calculated it could be on the week before October 3rd. So we shall see. But also when it comes close to Jupiter, there is a spacecraft
Juno.
there called Juno. And I wrote a paper about that.
I read your paper and I said, oh my God, this is a really good idea. So then I asked Molly Wasser from the Juno team, and they said to me that they don't have enough fuel to make maneuvers. So then I was like, oh no.
No, there is not enough fuel for an intercept. If it had all the fuel that it originally carried, then it would have been able to intercept 3i Atlas.
Yeah.
But even with 10% of that fuel, the amount that may be left there, it can get within, according to our calculation, within 25 million kilometers from 3i Atlas by March 2026. And I mentioned it to Congresswoman Ana Paulina Luna, who called me for an update about 3i Atlas. And I told her about the opportunity with Juno, and she wrote a letter to the head of NASA, Sean Duffy, to look into that. And my hope is that NASA will use all the space assets at its disposal to get us better information on 3i Atlas. One thing to keep in mind, during October, when it comes close to Mars and then to Venus, we won't be able to observe it from Earth because the sun will be in our way. So we will be on the opposite side of the sun.
Conjunction.
And you might argue that this could be by design, that it didn't want us to see what is happening during that time, because it's the best timing for a maneuver that will take advantage of the gravitational assist from the sun. That's what we often do with spacecraft when they come close to a massive object. We fire the engine of the rocket so that we are being helped by the gravitational force of the object. And so if 3i Atlas will do a maneuver, we won't be able to observe it from Earth, but we might see the consequences. And of course, the stock market may crash if it does a technological maneuver.
Yeah, let's just to make some step back, because the audience of the Inteligência Limitada maybe is not too expert in astronomy like you and Felipe, and just to explain to the people about the how we know that is the Oumuamua, Borisov, and 3i Atlas. It's not from the solar system, because we have a lot of objects here, and astronomers discover the NEOs, the asteroids, comets, and why these three is not from here, because we call them interstellar. And let's explain to the people why and how the astronomers know that this object is not from our neighborhood, but from another solar system.
Thank you, Sacani.
The answer is very simple.
Explain to me, to Avi. Avi. Okay.
Explain to Vilela.
Yeah,
to Vilela
yeah.
Too, yeah.
No, I mean, it's really simple. It's really simple. It's by the speed of the object relative to the sun. And if the object is moving too fast, it cannot be bound by gravity to the solar system. We all know that, if you throw a tennis ball up the air, it comes back to you. But if you were to throw it fast enough, or if you attach a rocket to the tennis ball such that it moves fast enough, it will escape the gravity of the Earth. That's what very often space rockets do. So there is a characteristic speed that you need to exceed in order to escape the gravitational pull of the Earth. And the same is true for the sun. The solar system as a whole, is dominated by the mass of the sun. And if an object is moving fast enough, for example, in the vicinity of Earth, it needs to move at 42 kilometers per second. That's a square root of 2, 1.4 times the velocity of the Earth around the sun. So if you were to move faster by 42% than the Earth moves around the sun, then you would escape the gravitational pull of the sun and you would get to interstellar space. So when we launch interstellar probes, there were 5 of them, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. These 5 probes reached a velocity above the escape speed from the solar system, and that's why they're on their way to leave the solar system. It will take them 10,000 years to get to the outer boundary of the solar system, the edge of the Oort cloud, which is at 100,000 times the Earth-Sun separation. This is the region where you find objects that are bound by gravity to the sun. And the most distant objects are just icy rocks that some of them we see as comets when they come very close to the sun. So the solar system ends at 100,000 times the Earth-Sun separation, and that's roughly half the distance to the nearest star, actually. There is Proxima Centauri, which is a member of a 3-star system, the Alpha Centauri system. That's roughly twice the distance to the edge of the solar system. And so you can imagine stars as being surrounded by, if each star has an Oort cloud, then it's just like billiard balls that are touching each other, so to speak, and passing near each other. And of course, every now and then they may exchange some rocks. So it's possible that the Oort cloud includes a lot of rocks that came from other stars, but the interstellar objects are objects that enter for the first time, and they are moving faster than the escape speed. So we can immediately tag them and say, oh, this object is too fast to be bound to the sun by gravity. And together with my student, Amir Siraj, we actually went to a catalog of meteors. These are objects that collide with Earth. So when they collide with Earth, they burn up in the Earth's atmosphere because of their high speed, and you get a fireball. And just to give you a sense, every year there is an object that is roughly meter in size, roughly the size of a person, that collides with Earth. And this is usually a rock from the solar system, and it produces as much energy as the Hiroshima atomic bomb. Every year. You don't hear about it in the news because the explosion takes place at an altitude of 50 kilometers. It doesn't do much damage on Earth. The Hiroshima atomic bomb destroyed, the city because it was by design. It exploded very close to the ground. But these objects that collide with Earth explode very high up and most of them don't do much damage. And we found in a catalog, so these explosions are documented by US government satellites because they are monitoring the Earth for ballistic missiles, and the heat emitted from the engine of ballistic missiles. They obviously knew about all the ballistic missiles that were launched from Iran last year. But every now and then they see the heat coming from a rock that collides with Earth, and they report about it to NASA that puts it publicly available. So we went to that catalog and found an object that collided with Earth with a speed that indicated that it's not bound to the solar system. And so we called it the first interstellar meteor. And that's from 2014. We found it only in 2019. And then a few years later, the US government confirmed that indeed this object is interstellar. I led an expedition to the Pacific Ocean to look for the materials of this object, because I wanted to find out if it's a Voyager-like meteor. Imagine Voyager leaving the solar system in 10,000 years, and then in 1 billion years colliding with some exoplanet, another planet around another star. And it would appear as a meteor, but and if astronomers are not curious about it, they would say it's a rock. But someone like me would go and check. And that's what I did actually 2 years ago. We went to the Pacific Ocean, and a Netflix documentary team came with me. They documented it, and the Netflix film will come out in 2026 about it, in about half a year from now.
That's great. That's great. And another point, that's the astronomers calculate the orbit about the objects, then, and then when we find a hyperbolic orbit and everything, plus the speed of the object. One question for you: when we start
just to explain the terminology, hyperbolic simply means that the object is not bound to the sun. That's all.
Yeah.
So that's the nomenclature. That if you see an object that is not in orbit around the sun, it means it came from outside. And by the way, just to explain, Oumuamua was practically at rest. Almost at rest in the frame of the Milky Way galaxy, the local frame of reference. It's called the local standard of rest. And the solar system just bumped into it. It's just like a buoy sitting on the ocean, and then a ship runs into it. That's what Oumuamua was. However, 3I Atlas was moving at 60 kilometers per second before it entered the solar system. That's a huge speed. And, you know, that makes it very different from Oumuamua.
Yeah, it's very different from Oumuamua.
One question for...
go ahead. Go ahead, Felipe.
I was just saying that I still believe that Oumuamua is more intriguing than 3I Atlas. What do you say?
Yeah, I agree with you. For several reasons. First, it was most likely disc-like shaped, which we don't often see, you know, with a size that is a length that is at least 10 times bigger than its width, because we saw the amount of light reflected from it changing by a factor of 10 as it was tumbling. Just think about a piece of paper that is tumbling in the wind, and if you look at it, you never see it edge on. You always see it sideways.
It's like this pen coming through the camera and then spinning like that, so the surface brightness changes for
by a factor of 10, except
by a factor of 10.
Yeah, it's not like a pen. It's more like a sheet of paper, you know, and it was flat based on the reflection of sunlight, and so that made it really weird. And I should say that 3 years later, the same telescope in Hawaii discovered another object. I argued that Oumuamua was pushed by reflecting sunlight, and this other object that was given the name 2020 SO was also pushed by reflecting sunlight. And then they took a spectrum of it and realized it's made of aluminum. And then they realized actually that was the upper stage of a mission to the moon that NASA launched in 1966. So we know that one was technological because we made it. The question is, who made Oumuamua? It shared the same properties. But my colleagues in academia, they argue, no, it's a dark comet. You know, they argued it not only back then. Now, I'm talking about December 2024. There was a paper published in a prestigious journal, Proceedings of the National Academy of Sciences in the US, and it was co-authored by the experts of, you know, on comets and asteroids, and they say, well, Oumuamua belongs to a class of objects that are dark comets. Now, what is a dark comet? It's a comet where you don't see the cometary tail and you notice that it's accelerating. And so what you're saying is, oh, it must be a comet, because why would it accelerate in a way that is non-gravitational? And I say you can't call it a comet until you see evidence that it evaporates. You know, and it's sort of like seeing an animal that has no stripes. Imagine an elephant. You look at an elephant, has no stripes, but You are used to seeing zebras. So you say the elephant is a zebra without stripes.
A dark zebra.
And that's what they are doing. And what I'm saying, a spacecraft, that has some additional force acting on it, has nothing to do with cometary evaporation, like 2020 SO, for example. You can't call it a dark comet, but that's the cheat. That's a cheat done by mainstream astronomers who are trying to represent science to the best of their ability, but they actually misrepresent science. Why? Because they pretend to know something. They pretend that it's a comet when they don't see a cometary tail. And I claim, that's not honest. We should be honest. If it doesn't show the properties of a comet, we cannot call it a comet. And maybe it's technological in origin. On January 2nd, 2025, this year, there was a report by the Minor Planet Center, which is the official body reporting about near-Earth objects. It was authorized to do that by the International Astronomical Union. And they said, here is a new near-Earth asteroid that we didn't know about before, and they gave it a name. And then someone pointed out to them that this object actually is moving along the path of the Tesla Roadster car that was launched by SpaceX in 2018. So it's not a rock, it's a car that was launched by Tesla, by SpaceX.
Tesla Roadster from Elon Musk.
The Tesla Roadster car, yeah. And so they removed it from their catalog, but they called it an asteroid just a day before that. And so there are many such cases where astronomers talk about rocks, some of which are not similar
That's not a rock.
but they end up being spacecraft or probes that were launched. So we know that we added a population of technological objects to all the rocks in the solar system. We know that because we observe every now and then, and astronomers make mistakes until they realize that this trajectory is occupied by some technological gadget. However, if someone else sent a technological gadget, we would not know about it ahead of time. And so the astronomers would obviously insist that it must be a rock or a comet. And I claim that this is not constructive, because for us to figure out the nature of the object, we need to get as much data as possible and not assume that it must be a rock, a natural object. And the problem is that not only that they insist on that, they ridicule the possibility that it might be, even though they know that humanity launched 5 space probes that go to interstellar space. Even though we know about it, they dismiss that as completely hypothetical and speculative. To imagine something like us doing it billions of years ago. Voyager will be on the opposite side of the Milky Way galaxy in 1 billion years. I did the calculation with a student of mine, and most of the stars formed billions of years before the sun. So there was plenty of time for gadgets that were produced by other civilizations to reach our backyard with the same technology that we already used, the chemical rockets. And it's completely reasonable to check each and every object that enters the solar system from outside, any interstellar object, to check whether it's natural or artificial. And because of 3i Atlas, I defined a new scale, and it's now called the Loeb scale, where 0 means that an interstellar object must be natural based on the data. It looks like it's a comet or an asteroid. And 10 means that it must be technological because it maneuvers, it emits artificial lights, or it broadcasts a message to us, and or it creates some probes that visit us from that object. So right now I give 3i Atlas a 4 on the scale between 0 and 10, and future data will decide if it's a 0 or 10. But we should be open-minded and not take the approach that the Vatican did 400 years ago, where anyone that says something different should be put, now it's not house arrest, but should be canceled on social media.
Two points just to explain to everyone that the first object, Oumuamua, when we detect it's far from Earth, we don't have a image, we don't have just have
Exactly.
a spectrum from the Oumuamua, and the point that we said here is the mysterious behavior of the Oumuamua. That's when it's close to Saturn, that we see a kind of acceleration in the object.
Right.
So when we discover Oumuamua, we said that's asteroid, but asteroid don't have this acceleration. Then the
Right.
astronomers right now
Right.
call the comets have acceleration because they have activity, tail,
Right.
and everything.
And the only problem is we didn't see the activity.
Yeah. Oumuamua, you don't see the activity, then the
So
astronomers call to a
yeah,
dark comet because this.
you are exactly correct. So Oumuamua was roughly the size of a football field, 100 meters,
Yeah.
and at the distance of a fraction of the Earth-Sun separation. Even the biggest telescopes that we have cannot resolve such an object.
Yeah.
We don't have a telescope big enough to resolve an object like that. But 3i Atlas is actually potentially 20 to 46 kilometers in diameter, 46 kilometers based on the latest Spherex data. And in that case, we might be able to resolve it with the camera, a relatively modest camera of half a meter aperture, that we have on high rise that is next to Mars. We could resolve it. So it really depends on the size of the object. And we never produced a spacecraft. Humanity never launched a spacecraft, bigger than 100 meters. Even if you include the fuel tank of Starship, the biggest rocket ever, it's still smaller than 100 meters. So Oumuamua was a piece of something big, and the 3i Atlas is like the size of Manhattan Island, but I should say that the science fiction writers like Arthur C. Clarke, he already envisioned
Rama.
in his book Rendezvous with Rama. Yes,
Rama.
he envisioned a visit
First
by a
contact.
spacecraft that is 20 kilometers, like a cylinder, 20 kilometers in diameter and 50 kilometers long. So roughly the dimensions of 3i Atlas.
And right now for you, after 8 years from Oumuamua,
Yeah.
what do you think that Oumuamua really are? It's a
Well, you see,
Nowadays.
because you never see Oumuamua anymore.
Again.
And
yeah,
and,
yeah, it's
that's
like going
a mystery for forever.
For the eternity.
Well,
Yeah.
it's like going on to a bar and seeing someone you are really curious about, and that someone leaves the bar and goes through the door to the dark street, and you can't really.
Oh man, you broke my heart. You broke my heart right now, man.
Well, I should tell you that this question of are we alone is the most romantic question in science, and Enrico Fermi, the physicist who won the Nobel Prize in 1950, he was in Los Alamos. He was part of the Manhattan Project, and they were talking about extraterrestrials after the war ended. And so in 1950, he was having lunch and he asked the question, well, it's quite possible that they exist, but if so, where is everybody? And if I was there, I would have told him, Enrico, this is a question that every lonely person asks. Where is everybody? And what you tell a lonely person is, don't be so pretentious. You are not that attractive. Your partner will not come to you. You need to go to dating sites. You need at least to look through the windows of your home and check whether you have neighbors. And Enrico, he was an experimentalist, but he didn't build a telescope to check, to look at the sky. That was his mistake, just asking the question. And a lot of people repeat the question and come up with all kinds of possible answers. One possible answer is called the dark forest hypothesis, that aliens are actually quite nearby, but we don't hear anything from them. They're silent because they're worried about predators, as if you are in a dark forest and there could be a lot of threats to your existence and you prefer to be silent and just observe. And so they might be observing us. And then if they decide at some point that we are developing technologies that could be a threat to them, they might visit us. And so maybe 3i Atlas is an example of that. I don't know. But my point to Enrico is, when you go on blind dates, like the one we're having with 3i Atlas, you should observe the other side rather than express opinions or answer hypothetically the questions. The way people usually do, they want to figure out an answer with the least amount of effort. And I say, no, you have to work. And as anyone knows, if anyone goes on dates, it's a lot of work. Because most of the time you don't find what you're looking for. So in this case of interstellar object, it may well be that most of the time we will find rocks. Nothing can be more disappointing than going on a date with a rock.
Yeah.
But I wrote an essay actually asking, should we message 3i Atlas? Should we send a message?
Avi.
Yeah. And I said, yeah.
Yeah. What are the limitations of current observation when it comes to confirming?
Yeah. So it's just first that the object is getting closer to the sun, so we will get much better data when it comes closer. So far, I can summarize what we know. We know that initially there was no evidence for a tail of gas or dust around it, but then the Hubble Space Telescope got the best image when the object was about on the 6th of August, when the object was about 3.2 times the Earth-Sun separation. And at that point, what we could see is that there is some glow of light ahead of the object, so it's not behind it. So something was evaporating from the surface of the object, and you could see the scattering of sunlight from that something in the sun-facing side of the object, but nothing behind. And then the Webb telescope observed it, and more recently, the SPHEREX Space Observatory observed it. So the Hubble Space Telescope first data was July 21st, and then the Webb telescope August 6th, and then SPHEREX a couple of days later, August 8 to 12. And what we see from SPHEREX, they reported first, is a huge plume of gas around it. By huge, I mean that the object may be tens of kilometers in size, and then you see a plume that extends out to 348,000 kilometers of mainly carbon dioxide, CO2. So 95% of the gas that they detected by mass is CO2. And then 5% of the mass of this cloud of gas is water. When most of the comet experts expected that it's a water-rich comet. That's the most common type of comets that we find in the solar system. But it seems like it sheds mostly carbon dioxide. And then the Webb telescope confirmed that and got very good spectrum of this gas. And it's not at all clear what is, as of now, what is scattering sunlight around the object that is producing the glow that we see in the Hubble Space Telescope image. It could be dust, but it could also be fragments of ice, either CO2 ice or water ice. And now, just recently, we started seeing the effect of the solar radiation and the solar wind on this plume of gas. We see that there is a small tail that is teardrop shaped, sort of like conical behind the object. So we see that. And moreover, the very large telescope in Chile that belongs to the European Southern Observatory detected nickel in this plume of gas without any iron. And usually nickel and iron appear together because they are produced in stellar explosions together. You never get nickel without iron, you get both of them. And in all the comets that we looked at, both of them appeared at similar proportions. And here there is an upper limit on the amount of iron, no iron detected, and only nickel. Now, the authors of this report say, well, maybe there is a channel for producing mostly nickel, but the channel that they imagine is called carbonyl, and that is a channel that we use in industry to make nickel alloys. Okay, so industrial production of nickel alloys is using the carbonyl channel. That's common practice, but in nature, we always find nickel with iron. So why is the plume of gas around 3I Atlas containing only nickel? Does that imply that it was industrially produced, technologically produced? That's another interesting puzzle. And then they also detected the cyanide around this object. So that's all we know as of now. We don't know. Now, I also calculated that if it's a 46 kilometer size nucleus that is producing this plume of gas, then, over a period of a year, you don't ablate more than 1 millimeter of the surface to produce this cloud even over a period of a year. So it's only the skin of the object that we are now seeing evaporating, and it could be just material, some dirt, on any solid object that was collected along the path, along the journey, produced by bombardment of cosmic rays. We don't really know. But as the object comes closer to the sun, it will get warmed up. As anyone that is familiar with interrogation tactics, when you want to get someone
pressure
to confess, you put the person under stressful environment. So that's what will happen to 3I Atlas when it gets close to the sun. It will be heated by the sunlight and gets hotter, and then maybe it will produce more gas. Or if it's a comet, we would see a beautiful plume of gas and dust around it. If it's something else, we might see a different behavior. And so I would say at this time, it brings a lot of puzzles. It's unusual in terms of its size, unless, it's a very compact object that is surrounded by a dense cloud of dust. But then why didn't we see a cometary tail to start with? And then it produces mostly carbon dioxide, not water. So it's not a water-rich surface that it has, the way that all the comet experts argued. Then it produces nickel without iron, which is the way that nickel alloys are produced technologically on Earth. So all of these things are puzzling. And why is it lying in exactly the plane of the planets around the sun and coming so close to Mars? My hope is, okay, so here is my thinking. I asked myself, will I be happier if it's a rock? Is it? And of course, in that case, in that case, there is no threat to humanity in that case. So maybe, at first blush, I would be happy. But then I realized that we desperately need, humanity, desperate. If you read the news every day, you realize that we desperately need a wake-up call, because we are engaged in conflicts on Earth, on this rock that we were born on. Most of the real estate is in interstellar space, and we are occupied with territories on this planet, zero-sum games. And that's very depressing, and it's sort of like being in a party where you see all the party comers misbehaving. And then you ask yourself, well, maybe someone else will come to the party to change the perspective on what's going on, and that's what I'm hoping for, that an interstellar visitor will change our state of mind and bring us to a better place. Then we would be inspired to do better and not fight each other and invest $2.4 trillion every year in military budgets. I think that after a wake-up call like that, we would take a fraction of the $2.4 trillion a year that we put in military budget and put it in space exploration. We can build a platform on which we can put humans, not necessarily go to Mars. Mars is a terrible place. It's a desert, no atmosphere, temperature changes by hundreds of degrees between day and night. Your body is destroyed by cosmic rays within a few years. So it's much better to build a habitat in space that humans can go to, a space platform, And I think it's the next step of humanity, because we came from the jungles of Africa and now we live in high rises in cities. And the next step is from high rises to get to space. And maybe the way to do it is for us to get someone to see another civilization that is doing better than us and realize, oh, we should do something more inspiring than we are currently doing. Instead of killing each other, let's work together. You know, we are all in the same boat here on Earth, and let's cooperate and work together. That's really my hope.
A common
Yeah,
enemy.
we have
Well,
we
just to
have
clarify to the everybody, that's the Three-Eye Atlas, people. It was discovered 1st July, so it's only 2 months of you discover this the third object,
Exactly.
and that's great because we have a lot of data, a lot of papers, a lot
Exactly.
of things, and just 2 months. And to clarify too, in 25 October is a perihelion, the close
No,
point.
29.
29,
Yeah.
sorry. 29 of October, it's the perihelion when close to the sun. And in the first and second week of October, he close to Mars. And Mars is
The 3rd of October, Mars.
third
3rd of October,
October
and then Jupiter is the 16th of March, 2026.
2026. Yeah. Just to clarify to everybody. So it's just 2 months that object. So we have a lot of question, of course, about this because it's 2 months. And one point to Avi, that everybody said that you make a contundent affirmation that is
No?
a techno. Yeah, I invite everybody. I invite everybody that listen you here now to read the medium of
Yeah.
the Avi Loeb. It's a very nice papers there. In all the papers that the AV write in the medium, he put the questions, and
Yeah.
that's
Well,
great.
let me
We
explain.
need to.
I can. That's an excellent point, and let me explain what is happening. What is happening is, I did not have a press release about my papers or articles. I wrote about 50 essays over the past 2 months
Uh-huh.
on Medium.com that were read by 600,000 people. That's huge. And I also speak on a lot of interviews and express my point. But I never, initially I never spoke to the reporters that reported about my papers, and they distorted the message by trying to argue that I claim that it must be technological because they wanted to get more clickbait. It's very clear that they are getting paid based on the number of readers, and so they distort the message. Now, I have no way of policing what anyone else is saying about my work. Okay, so the only way for me to behave responsibly is when people ask me to tell them what I think. Okay, and that's what I do through my writings. So if you read my writings, if you listen to my podcast, you will see clearly what my opinion is. But then what happens is these reporters, they get millions of readers, and the subject becomes viral on social media, and then even the AI systems are reading all the reports that are false. Okay, and so they create the impression as if I'm saying things that I'm not actually saying, and then some of my colleagues are using those reports in order to attack me. And this dynamics is really strange because I never said what they are saying that I said, and they get upset that the reporter said that I'm saying something and I didn't really say that. And they don't even check. They just attack me for what the reporter said. And so it's a vicious cycle. But since I have 600,000 people that read my Medium over the past month, a lot of people know what I actually say, and that moderates the blow. 5 years ago, when I was talking about Oumuamua, and it was exactly the same dynamics, it was more difficult for me because I didn't have as much visibility, and I was not really interviewed as much as now. I had over the past 2 months, on average, every day, about 5 to 8 interviews. So my voice gets out without me doing any effort. These, people are asking me for interviews all the time. While if I were to start being an unrecognized person, like I was before, then it's impossible to cope with that, because your colleagues would, especially if I was at an early stage of my career, I would be dependent on all these colleagues for funding, for my tenure, and for so that explains why you don't see a lot of innovation in science, because anyone that deviates from the beaten path is being punished by the so-called experts. And you might say, okay, well, maybe the mainstream should be conservative because they are often careful and they are doing the right thing. Well, let me tell you something. That's not true. Because when I started astrophysics 40 years ago, we still, we didn't know what most of the matter in the universe is. 85% is called dark matter. It's a substance that we've never found. And back then it was argued that the most natural particle to explain dark matter is the lightest, the lowest mass particle with a new symmetry of nature called supersymmetry, the lightest supersymmetric particle. And everyone said, yeah, that's a great idea. And the mainstream took it and said, we need to invest billions of dollars in the search for the lightest supersymmetric particle. And actually $10 billion were put into the Large Hadron Collider with the hope of discovering supersymmetry. That's at CERN. Not only discovering supersymmetry, but finding the dark matter. And guess what? $10 billion were invested. Nothing was found. Yeah. Supersymmetry does not exist in the original parameter space. And people that I know got honors, awards, promoted as part of the mainstream, saying this is a natural thing. String theory was basing its foundation on supersymmetry, and it was not found. So if the mainstream takes a direction for 40 years that ends up being wrong, okay, what is the solution to that? I'm not saying science is, you are in the dark, you don't know the answer in advance. Obviously, you can make mistakes. The mainstream made a big mistake here, okay? But the point is, if you take the entire cohort of practitioners and you basically herd it like a herd of sheep, you say all the sheep need to stay in the same lane, in the same path that we are thinking is the most likely one to bring discovery. If one of the sheep tries to deviate and go to a different path, you immediately ridicule that and put all the sheep under a tight configuration. Then you're not exploring other paths. You're losing the efficiency of science to make discoveries, because maybe the other path was the one that would lead to a discovery. And so the same thing happens here. Okay, it may well be the case that most of the interstellar objects are rocks. It may well be the case. But what's the problem with considering an alternative interpretation when you see something anomalous? Because, and the reason for that is, it will motivate observers to get more data. And if at the end we end up finding it's a rock, okay, we learned much more about rocks that arrive from other stars. And the other thing is, more important than this, is young people, they see me being attacked, okay? What is their conclusion? We are vulnerable. Those fledgling scientists, they don't have tenure, they don't have recognition, and they need to be careful because they will not get a job. So when they see those attacks about anyone that deviates from the beaten path, they realize they should be careful. It's a warning sign. And that's definitely the purpose of the attacks, also to frighten anyone from deviating. How dare you do that? You shouldn't consider anything other than comets until it hits you in the face. Like, if the Tesla Roadster car were to collide with Earth, which it might do in, let's say, 100 million years, and it lands in the backyard of one of these astronomers and you see a car instead of a rock, then it was actually not an asteroid, it was a car. But my point is that you need to collect data, and that's effort, that requires resources, time. And if you don't allow the possibility that the near-Earth asteroid is a car, and you don't know that it's a car, without taking the data, it's a self-fulfilling prophecy to claim that it must be a rock of a type that we've never seen before, because you don't have better data. And that is the method being taken by the mainstream, basically saying we should not put resources in the search for extraterrestrial intelligence. Instead, we should put all our resources right now, that's the main priority of the astronomy community, at least in the decadal survey of the American community of astronomers, to look for microbes. Look for microbes, more than $10 billion in the next 20 years. Let's search for microbes. And the situation is similar to you being at your home, and you know that there are microbes in your home because you can see them, the effect they have on food and other things. Then you look at the street and you see houses that are just like yours. And in the case of the solar system, you see other sun-like stars that may have a planet like the Earth, roughly at the same separation. There should be billions of them in the Milky Way galaxy. So there are houses just like yours. And you are saying, oh yeah, the microbes are probably most prevalent, they're most abundant, they must be everywhere, they should be in these houses, let's search for them. Well, good luck. Check through your window at a distance, check if your neighbor's yard or house has microbes. That's very challenging. It requires more than $10 billion to build a space telescope that would look for the chemical fingerprints of microbes in the atmospheres of exoplanets. More than $10 billion. I'm saying, we exist in this house. It's possible that one of the houses on the street has an intelligent species like us, or had one. And so maybe we will find a tennis ball in our backyard from that neighbor, or maybe that person will come to visit us, or maybe we'll see some construction project, in the backyard of their house. And these are things that are easier to detect. So even if residents are very rare on the street, much rarer than microbes, they might be much easier to spot from a distance. And I'm saying, let's hedge our bets, put similar levels of funding, billions of dollars, in the search for extraterrestrial intelligence as we do in the search for microbes. To me, it sounds like common sense. And the very negative response that I get to this proposal, implies that common sense is not common in academia. And frankly, I think one reason that we haven't heard from another intelligent species is because we are not intelligent enough to be open-minded to the possibility that they exist.
So, Avi, we were talking a few moments ago about wars and space wars, aliens coming to destroy us.
Yeah.
And then I just got reminded that we have three very good questions from Daniel. So,
okay,
Vilela, it's up to you.
Okay.
Okay, go ahead.
Solta.
Hi, I'm Daniel. It's an honor to talk to you and ask a question. I'd like to ask, what do you think about the fact that Presidents Reagan, Biden, and Paul Krugman, they said that an alien invasion would end all wars and bring peace to Earth?
Well, this is my hope as well. And
the common enemy. We need a common enemy to fight against.
Exactly, because you can think of the metaphor of kindergarten, where the kids are playing in the sandbox, throwing sand on each other, and then someone else shows up, and then they start behaving. That could happen, and that's really my hope. Because the other thing it will do is change our perspective, because we would realize that, first of all, there is much more out there than we imagined before. I think of humans very similar to large language models. The intelligence is based on the training data set. So, when my daughters were infants at home, they only knew about what happens in our house, in our home. That was their training data set. And they thought that they are the center of the universe, because they didn't do anything. They were the focus of attention by us, the parents. Obviously, as soon as they went to the kindergarten on the first day, they had a psychological shock to realize that there are kids just like them, some of which are more intelligent. And so I think we as a civilization did not mature yet. You have very prominent people still arguing that, we are probably alone and there is nothing else out there. I think it's very arrogant to imagine that, given that there are billions of Earth-Sun systems in the Milky Way galaxy alone, and perhaps even 1 trillion galaxies in the observable volume of the universe, and then many more beyond the cosmic horizon. And instead, we should be filled with a sense of cosmic modesty. It used to be the case that religions would tell people there is something more powerful than you are, and that is God. And when Friedrich Nietzsche in the late 19th century said God is dead, after that came the scientific and technological revolution. And we are currently living with this sense of hubris that, we are powerful, there is nothing better than us in the entire universe. And I think we desperately need a visit or an encounter with another civilization that would put us in the right mindset with a sense of modesty. And it could substitute for what in past generations was the image of God. I had religious scholars from Christianity Today that visited me at Harvard, and they asked me, what would be the impact of finding extraterrestrials on our religious beliefs? And I told them, look, I have 2 daughters, and when the second one was born, it didn't take away from the love that I have to my first daughter. And so it's really quite limiting to think that God is like a parent that can attend only to one child. And it's very likely that we have siblings out there. Now, of course, you might be jealous of your siblings, brothers and sisters that may be more accomplished than you are, but you will just get a better appreciation for God if there are more of them, not just us. And so they accepted that. And I don't think it's in conflict with people who have religious beliefs to find that we are not the only member of the club of intelligent civilizations. In fact, I think that we're probably in the middle of the class, and that we can learn from something much better than us and get answers. If we encounter and have a conversation with aliens, and by the way, never shake the hand of an alien because you don't know what diseases they carry, but at any event, you can speak with an alien.
Speak with an alien.
I mean, as I said, it's a blind date of interstellar proportions. And so if I had an opportunity to ask questions, the first question would be, what happened before the Big Bang? Because it will not only tell us about our cosmic roots, if they know the answer, but it will also inform us how to combine quantum mechanics and gravity, the 2 pillars of modern physics. And because we don't have a unifying theory, Einstein's theory breaks down when we go back to the Big Bang. That's when the density of matter and radiation was infinite. And we just don't know what happened before that. But if they know, then it would educate us about how to unify quantum mechanics and gravity. And the second question that I would ask, well, of course, I can ask also, what is dark matter? What is dark energy? The constituents of the universe that we have no idea about. But a more sociological question is, where is the nearest hub where all the intelligent civilizations come together and discuss things? I think it would be very helpful for us to meet them.
Okay. Leo, can you bring the second one?
The second question I'd like to ask you is if you have worked with security clearance, or have you worked with any secret project?
Not so far. I'm leading the Galileo project that basically takes the approach that I mentioned before of a kid trying to figure out, not believe stories. I'll give you an anecdote. Back on May 1st, I gave a briefing in the US Congress about the Galileo project that I'm leading. And the day before that, I went to a department in the Pentagon that is called the All Domain Anomaly Resolution Office, that was established to look back at reports on unidentified objects in the sky and figure out what they are. And I asked the members of that organization, what did they find? Did they find anything unusual? And they said, no. There were some cases where the data was not sufficient to say anything, but in all those cases where we could tell, it was human-made, all human-made technologies. And then the day later, I went to Congress and gave my briefing. And then after that, there was a discussion. And the person sitting next to me, Eric Davis, was saying, the US government is in possession of a dozen spacecraft that were retrieved in crash sites with pilots, biological pilots of
Wow.
4 different types. And then I asked my wife, who should I believe? These are very different stories. It cannot be that both of them are right. Because the office in the Pentagon was saying that they have access to all the data within government. They didn't, for a minute, consider the possibility that they might not have access to some data. So it's impossible to tell from a distance. And of course, we can wait for the government to release their data. But in my view, it's like waiting for Godot, the Samuel Beckett play. I would much rather look at the sky. If things are happening, we should be able to see them. Now, that's the premise of the Galileo project, but we had to design a completely new set of observatories because we want to monitor the entire sky all the time. And usually astronomers look at a small portion of the sky at any given time. And so even the Rubin Observatory is tiling the sky, but we want to look at objects that fly overhead. So we built a new type of observatory at Harvard University first, but now we made the copies in Pennsylvania and Nevada. And within a month, we also have the ability to triangulate, to actually have multiple units looking at the same object from different directions, so we can tell the distance. And once we have the distance of an object in the sky, we can also figure out the speed and the acceleration of the object. And so this would be extremely important in telling whether an object is performing beyond the flight characteristics of human-made technologies. And so starting within a month from now, we should be collecting data on a few million objects every year. And I don't need to listen to stories that people tell me. I can tell if we see any object that is not human-made in the sky at 3 locations. And that's the approach that FIFA, the World Soccer Organization, is adapting. You in Brazil, FIFA quite well. And when there is a dispute about a goal, they don't go to the goalkeeper or the players or the audience to ask, do you think there was a goal or not a goal? They use cameras, the instruments to figure out. And that's what the Galileo project is doing. Because, as I said, my biggest trauma as a kid was listening to the adults in the room. When I would ask a difficult question, they would pretend to know the answer. And then I realized you cannot trust people. Very often they have wishful thinking. And you see that if there is a car accident, different people involved in the car accident give you very different reports. We know that in the legal system, you put people in jail or sometimes on death row based on eyewitness testimonies. But some people were exonerated from death row after the DNA was found in the crime scene. And that shows you that despite the fact that people were convinced and testified that they are guilty, they were not guilty based on DNA. So that shows that it's really difficult to use humans as sources of data. And we know that from history, humans came up with lots of stories that had nothing to do with the truth. Just to give you an example, I visited Chichen Itza in Mexico, and the highest status in society, the tour guide was telling me the highest status was that of astronomers. And I was really excited because I said, wow, this is not true today. Back then they appreciated, all the politicians said the highest level in society should be astronomy. Now I asked why, okay? Why did they appreciate the science of astronomy more than we do today? No, the answer was because of a story. The story was that you can forecast the outcome of a war or any political move by looking at the positions of the planets and the stars. This is astrology. So politicians thought, they believed the story, and they thought by having astronomers around, they could advise us based on the positions of planets in the sky and stars. And they can advise us whether to go to war at this time of the year. And they believed that it makes a difference. So now we observed a lot of stars. We have much better data. And we know that the outcome of wars is not dictated by the stars or the planets. We know that there is no correlation. Okay? And so my point is, stories can mislead you. You will have the wrong concept. You might do the right thing, but for the wrong reason. And if you isolate what people tell you, the stories that they tell you, from the data, if you collect data and then use it to figure out the truth, then you are more likely to do the responsible things. You will not go to a war just because some stars in the sky happen to be in some positions. You would not decide that the goal was really a goal if the camera shows that the goal, the ball didn't pass the line,
Line.
And so that's the method of modern science, using instruments, not using people to tell you. And, there are lots of people who say, I noticed something really unusual in the sky, or I was abducted, or something happened. That is a good subject for studies by psychologists. For the same reason that all these people that criticize me and are not willing to entertain the possibility that 3i Atlas might be technological, and they are getting really upset. These are people who claim that they are scientists. I leave that as a problem to be solved by their therapists. I don't think I need to resolve that, because I'm just following the method of science, which is to rely on data, and I want as much data as possible. How do you tell the difference between a genuine scientist and a conspiracy theorist or a dogmatist? You give all of them a lot of data. The scientist would be happy, even if the answer would end up being different than what the scientist was hoping for. That's the method of science. So we learn something new. But a conspiracy theorist would be worried.
They never
The
change
same
their
as a
mind.
dogmatist, that it will be in conflict with their opinions. So, I really enjoy the method of science, and, I could be wrong, but I don't think that we should dismiss possibilities just because they are representing new knowledge. And we based our self-esteem on knowing rocks in the sky. Before 1803, most people thought that rocks cannot fall from the sky. It was ridiculed. And then there was a meteor shower that was witnessed in Liège, France, after which the scientific community suddenly said, oh yeah, rocks can fall from the sky. And now we understand, because the same rocks were the building blocks of Earth. So some building blocks were left behind in the solar system, and every now and then they collide with Earth. Okay, that's what these meteors are. So we understand it all makes sense, but to people it was completely counterintuitive, because we see rocks on the ground. Why would they fall from the sky? Now we are, I call it the Stone Age of space exploration, where all the comet experts expect everything in the sky to be rocks, even though we launched the technological objects. And I say, well, just think a little bit beyond what you are used to.
And what do you think about the idea to put some space crafts in like a Lagrange point to wait for the next
Excellent.
interstellar object?
Excellent
When
question.
we detect, we send the spacecraft to meet the object. What do you think about this? Because
Excellent.
your Galileo project is based in the observatories on Earth. Yeah,
Exactly. No, that's an excellent point. I wrote an essay a few weeks ago on medium.com that ask the question, what should humanity do on the day after we know that we were visited by a technological object from another civilization? And I had 15 points that I brought up to establish an organization that will interpret the data, decide how to respond to it, because it's a visitor to our backyard, and that's very different than getting a radio signal from thousands of light years away, where you have plenty of time to decide how to respond. When you have a visitor in your backyard, that visitor may enter through your front door. It's an immediate risk. You have to decide how to cope with that threat. So there will need to be decision making by policy makers, and it should be international because it affects all humans. But after the dust settles on this encounter, there would be long-range implications. And I believe that if we discover that there are technological objects visiting us, then we should have an array of interceptors and sensors that are, in orbit around the sun, and would provide a warning system as to something that is approaching us, and maybe even fly by any object, any interstellar object, to get a good photograph of it. And that could immediately tell us if there is a flyby with a photograph, you can tell if it's a rock immediately. By the way, I also see that as an exciting frontier. Even if it's a rock, if we can land on it with one of those interceptors and bring a sample of the materials back to Earth. We did it already with the OSIRIS-REx mission that visited the asteroid Bennu and brought 120 grams from the surface of that asteroid to Earth. And over the past year, that material was analyzed, and the scientists found that most of the amino acids, the building blocks of life, were found on this asteroid Bennu, and presumably because it was a piece of a bigger protoplanetary body that had some liquid water on it. And the point is that if we were to bring 120 grams from an interstellar rock, we could tell if the building blocks of life near another star are the same as near the sun. That would be amazing. And that's a completely different approach to astrobiology than the one adopted by the mainstream of astronomy. Right now, the mainstream says we should use telescopes to look at a distance and monitor the atmospheres of exoplanets. I'm saying getting a sample is very different, because it would take us millions or billions of years to visit other stars and get a sample. And here we have rocks that arrive to our vicinity from far away. They made the trip that took millions to billions of years. So we should take advantage of that. That's my new way of thinking about astrobiology, even if you think about rocks. But of course, if it's a technological gadget, there is an international security threat. We have to decide if we want to protect humanity. We need to decide whether it's a threat or not, and then potentially do something about it. And the other thing we should do is, of course, instead of thinking about going to the moon or going to Mars, these are just rocks that happen to be near Earth. And nature just gave us these additional rocks that are much worse to live on than to live on Earth. Why would we just go to another rock that is much worse? It's a desert, no atmosphere. So I'm thinking of it will inspire humanity to build a space platform that carries people. And it could be quite big. And then it would be a substitute to Earth, and potentially save humanity in the long-term future, because all kinds of catastrophes may happen to Earth, especially if there is a threat from alien technology. We talk a lot about the threat from artificial intelligence to the future of humanity, or from global climate change, or from an asteroid impact. We don't talk much about alien technology.
And
so,
when do you think that the next interstellar object will be discovered? In next month? By Vera Rubin? Or what do you think?
Yeah, so the Vera Rubin Observatory, if you do the calculation, should be able to find an interstellar object like Oumuamua or Borisov every few months.
Yeah.
And the Atlas telescope just scooped it. because actually in the early data of the Rubin Observatory from the beginning of June 2025,
Yeah.
this object was
Atlas,
already there.
o Atlas
But
will be
they
there,
just
yeah.
started operations and they didn't really do the good analysis. So, but every few months they will find one, and I think we should now, and we are entering a new era with a detection rate that is larger by 100 times than we had before. You know, over the past 8 years, we discovered 3, but now every few months we'll discover new ones. So it's a factor of 100 in detection rate. And
Great.
that should be very exciting. Or if you are a pessimist, it could be threatening. But it really depends. You know, people ask me, should we be worried? And I say, well, you know, if you go on a blind date, are you worried that you're meeting a serial killer? I mean, if you are positive minded, you
Great.
know, it's always exciting to go on a blind date.
Avi, I just want to clarify to the general audience about the Galileo project. I mean,
Right.
what is the Galileo project? It's
Yes.
all about studying like UFOs, isn't it? Or is it possible to people to get involved, to support, donate, work
Yeah.
with, and stuff like that?
Yeah, so I am leading the Galileo project that was established 4 years ago. And the idea was to monitor for any technological artifacts from other civilizations near Earth. I really I don't care about human-made technologies. If we see some unusual drone or anything strange in the sky that was human-made, I will pretty much ignore it. I don't care about it. So the challenge is when we get images of the sky, we in our observatories, we obtain it in the infrared, meaning that we can see objects even at night. We see the heat emitted from the objects. We don't need the sun to illuminate them. And we also observe in the optical band, meaning that we can see them during the daytime. And we also observe in the radio and audio. So we are taking a movie of the sky, basically, in all these different bands. And then we have machine learning software that identifies objects and decides whether they are familiar. So we are asking, are they helicopters, airplanes, drones, balloons, satellites? These are familiar objects. They could be also, instead of technological, they could be natural objects like birds or leaves or clouds in the sky. Sometimes, you know, they may fool you. And the machine learning software is getting better. The more data we have, the better it gets at identifying, you know, an airplane from different angles and different types of airplane and so forth. So we are planning to observe a few million objects per year with the 3 observatories that we have, and then use the machine learning software to tell us if there is any outliers that are moving in ways that human-made technologies cannot reproduce. Why are we doing that? Because there were 3 reports from the Director of National Intelligence in the US to the US Congress. And that led to the establishment of the organization I mentioned before, the All Domain Anomaly Resolution Office in the Pentagon, where the intelligence agencies were basically saying, we are not doing our job, despite the fact that we're getting a lot of funding. We cannot identify some of the objects in the sky, and I think it's a serious matter. So my point is, you know, as a scientist, I'm really curious to know if any of these objects is extraterrestrial. But if it turns out at the end of the day that all of them are human-made or natural, in which case I would not be very excited. I'm happy to give all the knowledge that we develop in terms of the system of sensors and also the software, the artificial intelligence software, to give it to the Department of Defense so they can use it to alert against any threats from adversarial nations, any espionage conducted by drones or other devices. And I will not feel that my time was wasted in leading the Galileo project. So as of now, we have several dozens of researchers. I just hired 3 new postdocs that are joining the Galileo project. Just today, they gave me, they agreed to the offer we made them. So we will have 3 new postdocs, and we have several others, and then some senior researchers. And we are operating right now on a budget of a few $1 million a year. And of course, any donations would be greatly appreciated. You can find the Galileo project on the Harvard website of the project, where there is a button, donate, if you are interested in contributing. Aside from looking for these objects, the Galileo project also is obviously interested in interstellar objects that the Rubin Observatory will find. And 2 of my postdocs will actually analyze the data coming from the Rubin Observatory, either looking for near-Earth objects or interstellar objects far away. That will be part of our important research in the coming year. When the Rubin Observatory starts giving us data, it will be publicly available, and we'll focus on that. We developed new algorithm software to analyze the data. And finally, I should say, I went on the expedition to the Pacific Ocean to look after the materials of the first interstellar meteor. And we hope to go again and look for bigger pieces, because we did find some small spherules, less than 1 millimeter in size, that were quite intriguing with unusual chemical composition. So we hope to go again, and that will cost $6.5 million. We are waiting for a donor. We do have the ship and the equipment that we need to use to find the bigger pieces. And we will simply put a robot on the ocean floor in the location of the search. And if we find the main core of the object, that could tell us whether it was artificial or a rock.
Where is Vilela? I think he was abducted because he's not saying anything.
Help me, Sacani.
Please go ahead, ask.
Yeah, no, I think that that is good to say to the audience. It's possible to know where is the origin of the Three-Eye Atlas, and what about the age of this object? They have a million years, billion years. What do you know at the moment? Because we know that we need more data and everything, but what do you know at the moment? From where they come, where Atlas come from?
So together with my student, we took the velocity of the object and went back in time to see where it may have come from. And we found that whereas Oumuamua, for example, came from the thin disk of the Milky Way galaxy because it was nearly at rest. And young stars are often, in the thin disk. They're made out of the gas that is lying in the thin disk. And the gas is cold, and you make new stars out of this gas in molecular clouds. And so Oumuamua.
Just one sec to explain to the everybody that the galaxy, the Milky Way, have two kind of disks. That's a thin disk and a thick disk. Yeah? Yes,
and the thick disk was originally a thin disk. So stars that formed a long time ago were in the thin disk, because all the stars are made out of dense gas, and the dense clouds of gas are in the thin disk because the gas is cold. To make stars, you need cold gas. But the old stars, since the time that they were formed, the Milky Way encountered all kinds of mergers with small galaxies. Also, there were clusters of stars passing through the disk, and they were steering it up. And as a result, the thin disk became thick, and it gets thicker with time. So you find the oldest stars in the thicker disk, and the youngest stars in the thin disk, because they just formed. And Oumuamua was in the thin disk. It didn't have much of a velocity out of the plane of that disk. So if it came from a star, the star must have been young, less than 1 billion years old, 1 to 2 billion years. That's based on our calculation because of the fact that it lies in the thin disk. And the stars in the thin disk are 1 to 2 billion years old. And on the other hand, Borisov came from some intermediate range of thickness. And therefore, it probably came from a star that has an age similar to the sun. The sun has an age of 4.6 billion years, which is exactly 1/3 of the age of the universe. It's the last 1/3. So the sun was made in the last third of cosmic history. And that's why we are late to the party. Most of the stars formed earlier, billions of years before us. So my point is, if you are not at the center of the party, because we know that the universe is not centered on us, right? And you arrive late to the party, the party is not about you, in the way that a lot of people think, and we better find someone else who will tell us what it's about. And so at any event, 3i Atlas actually has a speed of 60 kilometers per second outside the solar system. So it came with a significant deviation in velocity from the thin disk of the Milky Way, and it should have arrived from the thick disk, actually. So if it came from a star in the thick disk, then it must have been old. However, I should caution that you can develop a high speed just by the ejection mechanism. So imagine a planetary system like the solar system, and suppose you eject an object out of the solar system at 60 kilometers per second. It has nothing to do with the age of the sun. It's just that the process that gave a kick to the object endowed it with a very high speed. And that's a caveat that people in the community do not appreciate. You cannot say the age of an object because you don't know how long the journey took. And also the speed itself is not telling you, even if you think it came from the thick disk, it may not have come from the thick disk. It may have been from the thin disk and just got a large kick velocity as a result of the ejection process. So we don't really know, I would argue, the age until we figure out what was the ejection process of this object.
Yeah, the correlation between vertical speed and the age is very weak, right?
Well, it assumes that the ejection speed was. I mean, it's possible the ejection speed was small, but we don't know that.
Yeah.
And I can give you actually, in the context of this meteor that I mentioned, it also had 60 kilometers per second. And there is a natural process that will give you that. The most common type of stars is dwarf stars. These are stars that are 10% of the mass of the sun and 10% of the radius of the sun. And they are very dense. They are 100 times denser than the sun. They are 100 times denser than rock. So if you take a planet like the Earth and bring it close to the most common star, a dwarf star, the star will rip it apart, will spaghettify the planet, make the Earth a stream of molten rock. And half of that mass of rock will be ejected to interstellar space. And I wrote a paper about this a year and a half ago, and I calculated the speed by which the ejection will be. Turns out to be 60 kilometers per second. Okay, so here is a process which could be common that ejects material rocky material to interstellar space at 60 kilometers per second, but it has nothing to do with the age of the star.
Yeah, I was talking about the vertical speed in galactic coordination.
Yes, exactly.
In respect to the locust and the rest of it.
Exactly.
So, Vilela, I think have one final question.
Yeah.
Vilela, it's up to you.
Can I ask you a final question?
Any question.
Why do you think will be the decisive discovery?
Oh, because I'm an optimist, and there is a good reason why I'm an optimist, a rational reason, and that is because life is very often a self-fulfilling prophecy. If you are not seeking evidence, you will never find it. If you are asking, where is everybody, and not doing anything about it, you will stay alone. And because I'm searching, I'm an optimist because I think we will find something. I found my wife after searching. It was a very good experience. So because of that, and we are still married for now 26 years. So I believe that now that we are starting the new era where we will have a new interstellar object every few months, there is a significant probability that perhaps we will find some space trash or functional devices produced by another civilization, because their trash will be our treasure, and I don't think Elon Musk is the most accomplished space entrepreneur that ever lived since the Big Bang. 13.8 billion years ago, and I'm saying that out of a sense of modesty. I think that it's really not intelligent of us and of people in academia to insist that it's an extraordinary claim to imagine something like us next to another star. I think it's an ordinary claim, and it requires ordinary evidence. And one more thing, ordinary or extraordinary evidence requires extraordinary funding. So without putting the money and the time to do the search, we will never find it.
And do you really think we're gonna find the aliens
Yes.
in the next decade?
Yes,
Oh,
I'm hopeful, and
me too.
let's have a
Me too.
conversation when we do. I was asked whether I'm doing it just to get the Nobel Prize. Someone asked me, a podcaster, and I said, no, I don't care about the prize given by humans to humans. If I discover a sign of an unambiguous sign of extraterrestrial intelligence, I would spend all my time trying to figure out what it means. And I will do what Bob Dylan did, which is forget about the Nobel. I don't care about that. I'm saying that just because yesterday someone alerted me to a tweet that got 150,000 views, where a doctor in plasma physics suggested nominating me for the Nobel Prize because he thinks that perhaps 3i Atlas is technological. I don't know that yet. As I said, I gave it a 4, but I don't really care about what humans give to other humans. If there is a higher intelligence in interstellar space, I want to learn from it.
Avi, congratulations on your work, and thank you for your time, man. Thank you.
Thanks for having me. It has been really, the questions were excellent, and I really enjoyed the conversation.
Sacani?
Yeah.
Thank you, Avi. Thank you.
Jaime.
Thanks, Avi. Thanks, Vilela and Sacani, for the opportunity to talk about aliens. And I will finish with Arthur C. Clarke.
Oh, yeah.
Either we are alone in the universe or we are not. Both possibilities are equally terrifying.
Well, I would disagree with that. I would say being alone is more terrifying.
More terrifying.
More terrifying if we are alone, because then it means something really
Yeah.
bad. It's a waste, an enormous waste of space, if you think
Waste of
about
space.
it. The
Just
size of the
imagine-
universe is, the universe existed for 13.8 billion years, and it's, tens of billions of years in space, and it will be an enormous waste of space if we are the most, and also very disappointing, I should say. If we are the most
Yeah.
intelligent, that's it. What you read in the newspaper, that's the best that the universe could have
The- the-
accomplished. That's really disappointing. I think there is something much better than us out there, and we should find it.
Thank you, Avi. Bye-bye.
Bye-bye.
Bye.
Bye-bye.
Thank you.
As opiniões e declarações feitas pelos entrevistados do Inteligência Limitada são de exclusiva responsabilidade deles e não refletem necessariamente a posição do apresentador, da produção ou do canal. O conteúdo aqui exibido tem caráter informativo e opinativo, não sendo vinculado a qualquer compromisso com a veracidade ou exatidão das falas dos participantes. Caso você se sinta ofendido ou tenha qualquer questionamento sobre as declarações feitas neste vídeo, por favor, entre em contato conosco para esclarecimentos. Estamos abertos a avaliar e, se necessário, editar o conteúdo para garantir a precisão e o respeito a todos.